Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on top of page number 298, and today is our lesson number 199, problem number 15. Turn to page 298, problem number 15. It says Lynn and Mark each, okay, turn to the page and read it with me, problem number 15. Lynn and Mark each attempt independently to decode a message, and thus hence Lynn and Mark, L and M. We are given that we are told that if Mark will we are told that if the probability that Lynn will decode the message is 80.8, so there is 80% chance that L will succeed. We are also told that there is a 70% chance that M will succeed. Lynn and Mark, they are working independently, which is very important. They are working independently. In other words, the chances that L will succeed has absolutely nothing to do with what Mark does and vice versa. They do not influence. Their work does not influence each other. They are working independently, which is very important. Question simply is, what are the odds that they will both succeed? Because of the fact that they are both working independently, therefore the odds that they will both succeed is simply the product of two probability. That's all it is. That's all it is. So the probability that Lynn will succeed is 80%. We are told that. And the probability that Mark will succeed is 70%. Therefore the probability that both L and M will succeed is simply the probability of the chances that L will succeed times the chances that M will succeed. It's simply a product of the two probabilities, which is simply 80%, which is 8 over 10, and 70%, which is 7 over 10. 8 sevens are, I know 7 sevens are 49, 7 squared is 49. If you add one more 7 to 49, it becomes 56. So it's 56, 10 times 10 is 100, 56 over 100, or 0.56. Voila, that's your answer. Let's look at part B. Part B says, what are the odds that at least one of them will succeed? At least one of them will succeed. That's it, we're done with this part. I need the room, obviously. They're working independently. I just erased it, but you know it. At least one will succeed. Which is same as saying, what are the odds that either L or M will succeed? Which is simply their respective odds, probability that L will succeed plus the probability that M will succeed minus the probability that L and M succeed. Which, if you want to think in terms of Venn diagram, that is the overlapping area. So the odds that L will succeed is 80%, and that is 70%. And in the previous example, we just found out that the odds that they would both succeed was 56%. That's it, those are your odds. 80 plus 70 is 150, 150 minus 50, 150 minus 50 would have been exactly 100, and then we have another 6, so it's 94%. That's it, 94% chance that at least one of them will succeed. You see, individually, which is why if you put 2, 3 or bunch of more great minds together to solve a very complicated problem, even though individually they may not have very high odds of being successful, this guy has only 80% chance that he will succeed, and this guy only has 70% chance. But if they are working independently, it is highly unlikely that one of them will not find a solution. As you can see, we have a 94% chance of finding a solution. Imagine what would happen if you put 10 people together of this caliber. They will find a solution. 10 people working together on a problem. Now, when I say working together, I don't mean working together. I mean 10 people working independently on a given problem. At least one of them will find a solution that is given. Practically given, I should say. Let's do part C. Part C says, what are the odds that neither will succeed? Well, neither is very simple. The probability that neither will succeed is simply 1 minus the odds that at least one of them will succeed. I shouldn't write it like this. If you're going to write that as 1, then you have to put that as 0.94. Because it's the leftover part. If there is a 94% chance that at least one of them will succeed, then there is only 6% chance that neither will succeed. That's it. 6%, that's it. What I want to do last part is this problem that you see on the blackboard. If you're wondering what this is the homework for today. This problem is not in the book, which is why it's on the blackboard ahead of time. It's not in the book. I'm going to read it to you. I want you to solve this problem on your own before you watch tomorrow's video, okay? So here's the problem. It says, it's very similar to this one, you see, except here we have 2 people, L and M, here we have 3 people. Person A, B, and C work independently to solve a given problem. It is very important that they work independently. The likelihood of success for each is 1/4. One more time, the likelihood of success for each is 1/4, 1/3, and 3/5 respectively. In other words, chances are 1/4 that A will succeed, chances are 1/3 that B will succeed, chances are 3/5 that C will succeed. The question is very simple. The question has 3 parts to it. How likely is it that no one will succeed? Not one single person will succeed. 3 people working independently on a given problem when their odds of success are this much. As you can see, the odds are not very high actually. Here we have 80% and 70%. Here it's just 1/4, 25% chance, 33% chance, 60% chance. So first question says, how likely is it that no one will succeed? Second question, how likely is it that only A will succeed? Only A will succeed. Third question, how likely is it that A and B will find a solution to the problem that they're working on, but C will stumble. C will not find it. How likely is it that A and B will succeed, but not C? That's your homework for tomorrow. We'll work on it together tomorrow, okay? Bye now.